the equation of the diameter of the circumcircle of the triangle formed by the lines 3x plus 4y minus 7 equals to 0, 3x minus y plus 5 equals to 0, and 8x minus 6y plus 1 equals to 0, plus 1 equals to 0. Now, given equations of three sides of the triangle, equations of three sides. One side equation 3x plus 4y minus 7 equals to 0, second 3x minus y plus 5 equals to 0, third equation 8x minus 6y plus 1 equals to 0, plus 1 equals to 0. Now, required equation of diameter of the circumcircle of the triangle formed by the given three lines. Now, observe it. By observation, the first line and third line both are perpendicular to each other, because slope of the first line equals to minus 3 by 4 and slope of the second line equals to 8 by 6. Now, product of slopes equals to, we get minus 1. Now, product of slopes of two lines is minus 1, then the two lines perpendicular to each other, the two lines perpendicular to each other. Now, first line and third line perpendicular to each other. Now, second line must be hypotenuse. Therefore, the given lines form a right angle triangle, Now, a circle passes through three vertices of a triangle, then that circle is called circumcircle of the triangle, Now, only semicircle angle is right angle, then the hypotenuse of a right angle triangle is the diameter of the circumcircle. The hypotenuse of a right angle triangle is the diameter of the circumcircle. Now, required equation of the diameter. Now, equation of the diameter nothing but 3x minus y plus 5 equals to 0. 3x minus y plus 5 equals to 0. Third option. Let A and B non-zero real, then the equation of the line passing through origin and the point of intersection of the lines x by a plus y by b equals to 1 and x by b plus y by a equals to 1. Required equation of the straight line passing through origin and point of intersection of the given lines. Passing through origin and point of intersection of given lines. If suppose the given two lines 1 and 2, required line passing through point of intersection of the lines and origin, Actually, the procedure by solving two equations, solving 1 and 2, we get point of intersection of the lines. By solving two equations, we get point of intersection of the lines. After that, equation of the straight line passing through point of intersection of the lines and 0, 0, or by using 2-point form, we get equation of the straight line passing through 0, 0 and point of intersection. That is very lengthy process. Now, the required straight line passing through 0, 0, the required line passing through 0, 0. Now, a straight line passing through origin, then the constant term in the equation of the required line is 0. The constant term in the required line 0. Now, by using 1 and 2, just to eliminate a constant, we get the required equation of the line. Now, from first equation subtract second equation, we get x by a minus x by b plus y by b minus y by a equals to 0. Now, in first two terms x common, x into 1 by a minus 1 by b. Similarly, in second two terms minus y common, 1 by a minus 1 by b equals to 0. 1 by a minus 1 by b taken common, we get x minus y equals to 0 or x equals to y. The required straight line is x equals to y or y minus x equals to 0 or x minus y equals to 0. Then option is third option, y minus x equals to 0. If 4a plus 5b plus 6c equals to 0. Then the set of lines ax plus by plus c equals to 0, ax plus by plus c equals to 0 are concurrent at the point, Now, the given condition 4a plus 5b plus 6c equals to 0, the straight lines ax plus by plus c equals to 0 always passes through a fixed point, require the fixed point. Now, here the coefficient of a in the equation of the line, the coefficient of a is x. Similarly, coefficient of b y, coefficient of c is 1, coefficient of c 1. Now, in given condition coefficient of a 4, coefficient of b 5, coefficient of c 6. Now, compare the coefficients, we get x by 4 equals to y by 5 equals to 1 by 6. Now, equate first and last terms, x equals to 4 by 6 or that equals to 2 by 3. Similarly, y equals to, here y by 5 equals 1 by 6, y equals to 5 by 6. Now, the required fixed point is 2 by 3 comma 5 by 6, 2 by 3 comma 5 by 6. Now, first option is correct. For all values of k, the set of lines 3a plus 1 into x minus of 2a plus 3 into y plus 9 minus a equals to 0, plus 9 minus a equals to 0 passes through the point. Now, this line always passes through a fixed point, required that fixed point. Now, from given equation 3ax minus 2ay minus a, in these three terms a taken common, we get a into 3x minus 2y minus 1. In remaining terms, x minus 3y plus 9 equals to 0, minus 3y plus 9 equals to 0. Now, it is in the form of some L1 plus lambda L2 equals to 0, some L1 plus some lambda into L2 equals to 0. Now, the equation in the form of L1 plus lambda L2 equals to 0, it always passes through the point of intersection of the lines L1 equals to 0 and L2 equals to 0. Now, any line passes through point of intersection of the lines L1 equals to 0 and L2 equals to 0 is L1 plus lambda L2 equals to 0. Means it always passes through a fixed point. The line L1 plus lambda L2 equals to 0 passes through a fixed point, that is nothing but point of intersection of the lines L1 equals to 0 and L2 equals to 0. Point of intersection of the lines L1 equals to 0 and L2 equals to 0. Just by solving the equations 3x minus 2y minus 1 equals to 0, x minus 3y plus 9 equals to 0, x minus 3y plus 9 equals to 0. Now, just solving these two equations, we get the required fixed point. Now, actually procedure, now the coefficients of x or y equating, after that from one equation subtracting second equation, we get the values of x or y. After that value substituting in any one of the equation, we get another value. That is very lengthy process. Now, just to write the coefficients of x again. Here coefficient of x is 3, coefficient of x 1. Now, x by here AD minus BC minus 18 minus 3 equals to y by AD minus BC minus 1 minus 27 equals to 1 by minus 9 minus of minus plus 2. Now, just to equate x and y values, we get 3 comma 4. The required fixed point is 3 comma 4. First option. If the lines p minus q into x plus q minus r into y plus r minus p equals to 0, q minus r into x plus r minus p into y plus p minus q equals to 0, r minus p into x plus P minus Q into Y plus Q minus R equals to 0. Options: form an equilateral triangle, form an isosceles triangle, or concurrent, form a right angle triangle. Now observe it. If suppose three lines, one line L1 equals to 0, second L2 equals to 0, third L3 equals to 0, L3 equals to 0. If suppose L1 plus L2 plus L3, just adding the three lines, or L1 plus some constant lambda 1 into L2 plus some lambda 3 into L3 equals to 0. Now if this condition satisfy, then compulsory the three lines are concurrent. The three lines are concurrent. Or by adding the three equations, we get P minus Q plus Q minus R plus R minus 3 into X. This complete sum equals to 0. Now we get 0 into X. Plus similarly, Y taken common, Q minus R plus R minus P plus P minus Q also 0 into Y, constant also 0. Now the sum of three equations equals to 0, then the three lines are concurrent. The three lines are concurrent. Option is third option. The lines Px plus Qy plus R equals to 0, Qx plus Ry plus P equals to 0, Rx plus Py plus Q equals to 0 are concurrent then. If suppose, observe it, the three equations adding, we get 0, or x equals to 1, y equals to 1, the three equations satisfy. X equals to 1, y equals to 1, the three equations satisfy. The three lines are concurrent. Now in that case, if x equals to 1, y equals to 1, we get P plus Q plus R equals to 0. P plus Q plus R equals to 0. Now first option may be correct. Now P plus Q plus R equals to 0, then here P plus Q equals to minus R. Now cubing on both sides, P cube plus Q cube plus 3PQ into P plus Q equals to minus R cube. P cube plus Q cube minus R cube, take left side, plus R cube. But P plus Q equals to minus R. P plus Q equals to minus R, replacing 3PQ into minus R minus 3PQR. Now taking right side, we get 3PQR. Now P cube plus Q cube plus R cube equals to 3PQR. Now second option also correct. First option correct, second option correct. If suppose P equals to Q equals to R, P equals to Q equals to R, now the first equation becomes to x plus y plus 1 equals to 0. Similarly, second equation also x plus y plus 1 equals to 0. Third equation also x plus y plus 1 equals to 0. Now in that case, the three lines, coincident lines, or concurrent may be. If P equals to Q equals to R, now the three lines are concurrent lines. Now in third option, substituting P equals to Q equals to R, now that condition also satisfies. Then the first, second, third, three are correct. Then fourth option is correct. All the above is correct option. If the point of intersection of Kx plus 4y plus 2 equals to 0, comma, x minus 3y plus 5 equals to 0 lies on the line 2x plus 7y minus 3 equals to 0, 2x plus 7y minus 3 equals to 0, then k equals to, require the value of k. Now point of intersection of first two lines, the point of intersection of first two lines lies on the third line, point of intersection lies on the third line, then the three lines are concurrent. Then point of intersection of any two of the lines substituting in the third equation that must be satisfied. Otherwise, the determinant of coefficient matrix equals to 0. K 4 2 1 minus 3 5 2 7 minus 3 equals to 0. Just expanding the determinant, we get the value of k. Now, the value of k equals to 3. Option is second option. If the lines ax plus by plus c equals to 0, bx plus cy plus a equals to 0, cx plus ay plus b equals to 0 are concurrent, then point of concurrency, the three lines are concurrent or passing through a fixed point, require that fixed point. Now, just observe it. If x equals to 1, y equals to 1, x equals to 1, y equals to 1, substitute in the first equation, we get a plus b plus c equals to 0. Similarly, in second equation also substitute, we get a plus b plus c equals to 0. Third equation also satisfies same thing, a plus b plus c equals to 0. Then the point of concurrency equals to 1 comma 1. 1 comma 1 is the point of intersection of the lines or point of concurrency. Now, second option. The point of concurrency of the lines x by 3 plus y by 4 equals to 1, comma x by 4 plus y by 3 equals to 1 and x equals to y, the point of concurrency of the lines. Now, the three lines are concurrent at one point, required point of concurrency. Now, it is nothing but point of intersection of any two lines from the given three lines, because all the lines passing through same point. Now, by solving 1 and 3, first line and third line, now in the equation at place of y equals to x substitute, we get x by 3 plus x by 4 equals to 1, or 4x plus 3x, 7x by 12 equals to 1. Now, x equals to 12 by 7, but x equals to y also. Now, y equals to 12 by 7. Therefore, point of concurrency is 12 by 7 comma 12 by 7. The point of concurrency is 12 by 7 comma 12 by 7. Third option. If theta is acute angle between the lines, y equals to 2x plus 3, y equals to x plus 1, then the value of tan theta, now theta is acute angle between the given two lines, required the tan theta value. Now, the equation in the form of first line in the form of y equals to mx plus c, second is also in the form of y equals to mx plus c. Now, slope of the first line m1 equals to 2, slope of the second line m2 equals to 1, slope of the first line m1 equals to 2 and slope of the second line m2 equals to 2. If m1 and m2 are slopes of two lines and angle between two lines is theta, then tan theta equals to m1 minus m2 by 1 plus m1 m2. Tan theta equals to m1 minus m2 by 1 plus m1 m2. Now, tan theta equals to, here the values of m1 and m2, 2 and 1, 2 minus 1 by 1 plus 2 into 1 or 2, or that equals to 2 minus 1, 1 by 1 plus 2, 3. Now, tan theta equals to 1 by 3. Now, option is second option. The angle between diagonals of a quadrilateral formed by the lines x by a plus y by b equals to 1, x by b plus y by a equals to 1, x by a plus y by b equals to 2, x by b plus y by a equals to 2. The angle between diagonals of the parallelogram or quadrilateral formed by the four lines. Now observe the four lines. In that four lines, 1 and 3 parallel to each other, because the coefficient of x in the first line 1 by a, in third line also 1 by a, coefficient of y in first line 1 by b, third line 1 by b. Then the lines 1 and 3 are parallel. Similarly, second and fourth lines are parallel. Now the lines form a parallelogram or square or rectangle or rhombus. The given lines form a parallelogram or square or rectangle or rhombus, but adjacent sides not perpendicular to each other. 1 and 2 not perpendicular, 2 and 3 not perpendicular, 3 and 4 not perpendicular. Then the lines not form a square or rectangle. Now the given four lines form a parallelogram, otherwise rhombus. The given four lines form a parallelogram or rhombus. Now the distance between 1 and 3, the two parallel lines, the distance between parallel lines equals to C1 minus C2 by square root of a square plus b square under modulus. Now the distance between 1 and 3 equals to 2 minus 1 by square root of 1 by a square plus 1 by b square, or that equals to 1 by square root of 1 by a square plus 1 by b square. Similarly, the distance between second and fourth lines, also we get 1 by square root of 1 by a square plus 1 by b square. Now the distance between parallel sides are equal, then the lines form a rhombus, not a parallelogram. The given lines form a rhombus, then angle between diagonals of the rhombus equals to 90 degrees. Now answer is fourth, pi by 2. The angle between the lines kx plus y plus 9 equals to 0, y minus 3x equals to 4, is 45 degrees. Then the value of k is, now the slope of the first line equals to, or m1 equals to minus k, slope of the second line m2 equals to 3. Now slope equals to minus coefficient of x by coefficient of y. Now that equals to slope of first line m1 equals to minus k, slope of the second line minus coefficient of x by coefficient of y, that equals to 3. Now m1 and m2 are slopes of two lines and angle between two lines is theta. Then tan theta equals to m1 minus m2 by 1 plus m2 m1 m2 mod. Now but theta equals to given 45 degrees, tan 45 1 equals to mod of 3 minus of minus plus k by 1 minus 3k. Now removing modulus, we get 3 plus k by 1 minus 3k equals to plus or minus 1. 3 plus k by 1 minus 3k equals to plus or minus 1. If taking plus sign, we get 3 plus k equals to 1 minus 3k, 4k equals to minus 2, for implies k equals to minus 1 by 2. Now one of the value of k is minus 1 by 2. Similarly, take minus sign, we get 3 plus k equals to minus 1 plus 3k. Now 2k equals to 4, for implies k equals to 2. Now the values of k minus 1 by 2 or 2 or minus 1 by 2. Now second option. The perpendicular distance from 1, 2, the perpendicular distance from 1, 2 to the straight line 12x plus 5y minus 7 equals to 0 or equals to 7. Require the perpendicular distance from given point to given line. If suppose the point x1 by 1 the straight line ax plus by plus c equals to 0. Now perpendicular distance from x1 by 1 to the straight line is ax1 plus by1 plus c by square root of a square plus b square under modulus. The perpendicular distance from x1 by 1 to the straight line ax plus by plus c equals to 0 is ax1 plus by1 plus c by square root of a square plus b square. Now that equals to, substitute the point 12 plus 10 minus 7 by square root of 12 square plus 5 square, or that equals to 12 plus 10, 22 minus 7, 15 by square root of 12 square plus 5 square, 13. Now 15 by 13. Now first option is the correct. The vertices of a triangle are a5, 6, b1, minus 4, c minus 4, 0. The vertices of a triangle are a5, 6, b1, minus 4, c minus 4, 0. Then the length of the altitude through the vertex A, the length of the altitude through the vertex A. Now triangle ABC, a5, 6, b minus 1, 4, c minus 4, 0. Require the length of the altitude through the vertex A. It is nothing but the length of the perpendicular from vertex A to BC, or perpendicular distance from vertex A to the side BC required. Perpendicular distance from A to BC. Now first the equation of the straight line passing through 2 points 1, minus 4, minus 4, 0. 1, minus 4, minus 4, 0 is. Now y minus y1, y minus of minus plus 4 by y2 minus y1, 0 minus of minus plus 4 equals to x minus x1 by x2 minus x1 minus 4 minus 1. Now y plus 4 by 4 equals to x minus 1 by minus 5. Now by cross multiplication we get 4x plus 5y plus 16. 4x plus 5y plus 16 equals to 0 is equation of the side BC, equation of the side BC. Now required perpendicular distance from vertex A5, 6 to this line, perpendicular distance. Now perpendicular distance formula ax1 plus by1 plus c by square root of a square plus b square under modulus. Now that equals to 20 plus 30 plus 16 by square root of 4 square plus 5 square under mod. That equals to 20 plus 30, 50 plus 16, 66 by root of 16 plus 25, 41. Now 66 by root 41, first option. The distance between the parallel lines 8x plus 6y plus 5 equals to 0 and 4x plus 3y minus 25 equals to 0. The distance between the two parallel lines. If suppose the lines ax plus by plus c1 equals to 0, second line ax plus by plus c2 equals to 0. Now the distance between these two parallel lines equals to mod of c2 minus c1 by square root of a square plus b square. The distance between the parallel lines ax plus by plus c1 equals to 0 and ax plus by plus c2 equals to 0 is c1 minus c2 by square root of a square plus b square under modulus. Now in this case, by using this formula, compulsory the coefficients of x and coefficients of y must be same. Coefficients of x and coefficients of y in both equations must be same. But in given equations, in first equation coefficient of x is 8, in second equation 4. Coefficient of y in the first equation 6, in second equation 3. Now, in that case, the second equation completely multiply with 2. Now, we get the second equation becomes to 8x plus 6y minus 50 equals to 0. Now, coefficients are same. Now, use the formula C1 minus C2 by square root of a square plus b square under mod. Now, C1 minus C2, 5 minus of minus plus 50 by square root of 8 square plus 6 square. Now, that equals to 55 by 10 or that equals to 11 by 2. The distance between the given parallel lines is 11 by 2, third option. The equation of the line which is parallel to 5x plus 12y plus 1 equals to 0 and 5x plus 12y plus 7 equals to 0 plus 7 equals to 0 and lying midway between them and lying midway between them. Now, the given two lines are parallel to each other. The given two lines parallel to each other. Now, the required equation of the line parallel to these two lines and midway between them, parallel to these two lines and equidistance from the two lines, equidistance from two lines. If suppose the first line ax plus by plus c1 equals to 0, second line ax plus by plus c2 equals to 0, then equation of the line equidistance from these two lines and parallel to these lines equals to ax plus by plus c1 plus c2 by 2. Just average of constants c1 plus c2 by 2 equals to 0. Then the required equation 5x plus 12y plus 1 plus 7 by 2 or that equals to 5x plus 12y plus 4. The required equation of the line 5x plus 12y plus 4 equals to 0, third option. The foot of the perpendicular from 3, 4, the foot of the perpendicular from 3, 4 on the line 3x minus 4y plus 5 equals to 0. The foot of the perpendicular from 3, 4 on the line 3x minus 4y plus 5 equals to 0. Now, the given straight line 3x minus 4y plus 5 equals to 0. The given point 3, 4. If suppose a perpendicular is drawn from given point on the given line, it meet at one point. Now, that point is called foot of the perpendicular of the point, foot of the perpendicular of the point on the line. Now, if suppose the given point A, consider P be the foot of the perpendicular. Now, PA perpendicular to the line, given line. Now, the perpendicular line is 4x plus 3y equals to, substituting the point 12 plus 12, 24. Now, the equation of PA is 4x plus 3y equals to 24. It is considered equation 1. The given line 3x minus 4y plus 5 equals to 0. It is second. Just solving two equations, we get the foot of the perpendicular of the given point on the line. Now, that is option 1. We get 81 by 25, 92 by 25. The point of intersection of these two lines 81 by 25, 92 by 25. First option is correct. If 2, minus 3, the foot of the perpendicular from minus 4, 5, foot of the perpendicular from minus 4, 5 on a line, then its equation on a line, then its equation. Now, 2, minus 3 is foot of the perpendicular from minus 4, 5 on a straight line, line equation consider L equals to 0. Now, required equation of the straight line, equation of the line. If suppose the given point, first point 2 comma minus 3 consider as P. Now P 2 comma minus 3 is foot of the perpendicular of minus 4 comma 5. This point consider A. Now the foot of the perpendicular of A on the line L equals to 0 is P minus 2 comma minus 3. Required equation of the line. Now PA perpendicular to required line. Now first slope of PA. Slope of PA equals to 5 minus of minus plus 3 by minus 4 minus 2, or that equals to 8 by minus 6 or minus 4 by 3. Now slope of PA equals to minus 4 by 3, but L equals to 0 perpendicular to PA. L equals to 0 perpendicular to PA. Then slope of L equals to 0 is 3 by 4. Now slope of the line L equals to 0 is 3 by 4. Now required equation of the straight line L equals to 0. Required equation of the straight line L equals to 0. Now you know slope 3 by 4 and passing through the point 2 comma minus 3. Now equation of the line y minus of minus plus 3 equals to m into x minus x1. Now we get 3x minus 4y minus 18 equals to 0. 3x minus 4y minus 18 equals to 0. Second option. Suppose A comma B are 2 points on the line 2x minus 5 plus 3 equals to 0. On the line 2x minus 5 plus 3 equals to 0 and P1 comma 2 and P1 comma 2 is such that PA equals to PB. PA equals to PB. PA equals to PB. Then the midpoint of AB is the midpoint of AB. The given line 2x minus 5 plus 3 equals to 0. On this line A and B are 2 points. A and B are 2 points. Now P is a point. P coordinates given 1 comma 2. P1 comma 2. Now required the midpoint of AB, but PA and PB are equal. Given condition PA equals to PB. Given PA equals to PB, then required midpoint of AB. Midpoint of AB. Now in triangle PAB, PA equals to PB. Now two sides are equal. Then triangle PAB is an isosceles triangle. Now a perpendicular is drawn from vertex to base of an isosceles triangle. Then it compulsory meet at midpoint. Then the midpoint of AB nothing but foot of the perpendicular of 1 comma 2 on the line 2x minus 5 plus 3 equals to 0. The midpoint of AB nothing but foot of the perpendicular of P1 comma 2 on the line 2x minus 5 plus 3 equals to 0. Now first the equation of the line passing through 1 comma 2 and perpendicular to the line 2x minus 5 plus 3 equals to 0 is x plus 2y minus 5 equals to 0. The line 2x minus 5 plus 3 equals to 0. Just to solving these two equations, we get midpoint of AB. That is nothing but minus 1 by 5 comma 13 by 5. Minus 1 by 5 comma 13 by 5. Answer is 1.